Hello everyone, welcome back to Skill Talk. In this video, we are going to discuss one of the most powerful but mostly misunderstood concept in the vibration analysis, that is the phase. So many people focus only on the vibration levels and the spectrum, but that phase is known as the confirmation of the problem. So because it helps us to separate one fault from the another. So today we will be understanding that what phase really means and normally how it is measured, and the third one that we are going to discuss is that how it will help us to help us in the fault diagnosis, like unbalance, misalignment, soft foot, or looseness, or so on, right? So let's start with the basic one, that is the definition of the phase. So what is phase? So phase is the simply the timing relationship between two vibration signals. So normally it tells us that how much one vibration signals lead or either lags with another one. So normally the phase is measured in degrees, so it can be from 0 to 360 degrees. So just to take one easy example, let's imagine that there are two sine waves. So if both sine waves rise and fall together, that means we will be saying that both the signals or both the sine waves are in same phase, okay? Or we can say the phase difference is 0 degree. And if let's say that one wave starts later compared to the another one, then we can say that these two signals are having some phase differences. In the same way, if let's say that if one wave is exactly opposite of the other, so that means these two signals are out of phase. So overall the phase is not about that what is the magnitude or the amplitude of the vibration. It's all about the timing. So now we will be to clear this topic more, so I will be taking one simple everyday example. So let's say that think of the two people that who are doing the clapping. So if both clap at the same time, then what we will say, that both have clapped with the 0 degree phase difference. If let's say one clap slightly later than another person, so then what we'll say, there is some kind of a phase difference between these two claps. And if let's say one is clapping exactly when the other stops, so in that case what you say, that both are clapping at 180-degree phase difference. So I believe this example make it little bit more clear to, or you can say easy to understand, right? So now we will be discussing that how phase is measured, okay? So to measure phase, we always need two references. So first one will be the, let's say, the vibration sensor, which is also known as accelerometer, or the second we can take as a phase reference, or you can say as a tachometer or the laser trigger. So it's not always necessary that you should be having one sensor and one tachometer for the phase difference. You can also use two vibration sensors or two accelerometers also for taking the phase difference, okay? But now here we will be discussing about that. Well, let's say that we are having one vibration sensor and one we are using the tachometer to measure the phase of our equipment, okay? So what tachometer will tell us? The tachometer will tell us the exact position of the shaft, okay? And the vibration sensor, that is the accelerometer, it will give me a clear sine waveform, or you can say the clear vibration signals from the equipment, okay? So normally what will happen now, this vibration analyzer that you will be using, that can be of any brand that you like, what they will do, they will be measuring the shaft position, okay, with the help of the tachometer, and also they will be measuring the vibration signal timing with the help of the accelerometer. And by having these two signals, they will be calculating the phase angles, okay? So this is how any of the device will be using two references to calculate the phase angles, or you can say the phase differences, right? Now, why phase is so important in the machines? Okay, so because there are multiple faults created in the machine, and there are most of the faults which are creating some similar kind of frequencies in the spectrum. So let's say that let's take one example of very basic faults, that is the unbalance and misalignment, okay? So they both, that they both can show the 1x, or you can say the first multiple of the RPM, right? So because now many of you can argue that in the misalignment, not only the 1x, will be getting the 2x and 3x. It's fine, you are right, but it's not always true. In some cases you will be seeing that maybe the 1x is too dominant in the misalignment and 2x is following, but it's somewhere around 30% of the amplitude of of that 1x. So here we are not arguing this, just we are just comparing that how phase can be used to make a confirmation between these two problems. Okay, so now let's take example. Let's say one machine is having the unbalance issue. Okay, giving sorry the is one machine is giving the symptom of 1x. So now 1x can be the unbalance or can be the severe misalignment. Okay, but now the thing is this, the phase difference, okay, or you can say the phase behavior will be different for that machine. So that's why the phase is extremely important. And if you want to have a like kind of a confirmation of any of the fault, right? So we will be taking few examples, the normal examples here. Let's take first example of unbalance. Let's say that there is a simply supported fan, and I have put on my accelerometers and the reference tachometer there. So in that case, what will happen that if the machine is having the unbalance, so the both the bearings, that is the one is the driven bearing, another one is the non-driven bearing, they will be moving in phase, mostly in phase. Okay, plus minus 30 degree, but mostly in phase. That means if the same time when the drive end housing is moving upwards, in this at the same time non-drive will also move upwards. Okay, when they are coming down, then they both are coming down simultaneously, right? So this is in this case the both phase is stable. Okay, and this mostly indicates the problem of unbalance. Okay, in the same way, if I will be taking the phase difference of by putting one accelerometer in the horizontal and one in the vertical, so in that case what will happen, the phase will be slightly lag. Okay, lag of around somewhere around 90 degree, because the unbalance create a one kind of jerking kind of force. So that's why one force will be lagging behind if I will be measuring the phase difference at one particular bearing housing. It can be either drive end or non-drive end. But once I am using the cross, that means one I am putting the sensor in the, let's say, the horizontal in the non-drive end side and another sensor in the horizontal non-drive end side, then both will be in phase. Okay, now if the same case, if I will talk for the misalignment, what will happen that if I will put my one sensor in the let's say in the axial side of driven side and another sensor in the axial side of non-driven side, in that case what will happen that the movement of both the housing will not be in phase. That means if the driven side housing is coming inwards, okay, and then in that case what will happen, the non-driven side of housing will be going outwards. So normally now you will say that how you will be will be calculating, or you can say that the both the housing of the fans are having the can have the misalignment. Of course they can't have the misalignment. So in that case what will happen, the one of the axial sensor you will be putting towards the fan fan drive end, and another sensor you will be putting at the motor drive end. So okay, in the axial side, because the misalignment, the probability of the misalignment is near the coupling, it's not across the fan. So all the condition mounted people who are guessing this, it's right. So in that case where I will get the 180-degree phase shift is between the motor drive end and the fan drive end in axial side. So whenever the motor is moving towards the fan is moving outside, and whenever fan is moving towards the motor side, the motor is moving outside. Okay, so this is known as the 180-degree phase shift, right? Now in the same way we can take the example of soft foot, where the phase will be changes. Let's say the one of the foot of the motor is having the soft foot issue. In that case, whenever you will tight or loose the bolt, the phase will be frequently unstable, or it will be frequently changing. And the same thing will happen in the mechanical looseness. The phase will become unstable, and you will not find any kind of a fixed relationship. Let's say that this is that 90-degree phase shift or 180-degree phase shift, it will be a unstable phase. And same way, if you talk for the resonance also, once the machine will be very close to its critical frequency, the resonance shift will be mostly by 90 degrees. So immediately the phase will start unstable and it becomes shift by 90 degree. Okay, so now overall, let's take one practical example of a practical motor. Okay, so let's say that I have measured the phase on the outboard bearing, or you can say the non-drive end bearing. The phase is 35 degree, and in the inboard bearing I have taken the phase, so the phase is, let's say, around 38 degree or maybe the 45 degree or something like this. So both are nearly in the same phase. So though we can say that okay, it's giving the symptom of the unbalanced. Okay, now in the another case, let's say the outboard bearing is let's say giving you the 40, and the inboard bearing is giving you the 120. So it's a kind of a symptom of a misalignment, right? So this is how, it's just a normal example. It's that to have a difference that how the phase can be useful in the life of a vibration analyst. So overall summary, to have a summary of this video, that phase shows always a timing relationship. Okay, it's never there is no meaning, or we can't compare the phase based on the severity. Okay, or you can say the amplitude. It's just a simple timing relationship between two signals. And phase always help us for the confirmation of the problem or confirmation of the fault, and the overall vibration level just always and only tell us that how bad the vibration is. Okay, and the spectrums tell us that the perfectly that at what frequency the problem is. And the phase, finally, it's a kind of a nail in a coffin, that it will tell us that why this is happening, or you can say the confirmation of that problem. So that's why phase is considered as an advanced but extremely most powerful diagnostic tool. Okay, so now I will be giving you in the end a challenge. Okay, so all of you can answer this for these questions in the comment sections. Okay, so the first question will be for you guys, that if let's say that if both the bearings are having the same phase, or you can say the same phase angles, so what fault can be likely? Okay, if the both the bearings are having the same phases, then what will be the fault? Okay, the question is clear. This is the question number one, so you can put on one and your answer. So the second question is, let's say that if the phase is continuously jumping when you are tightening one of the bolt, then what kind of fault you believe that can be in the machine? Okay, so for this question you can put on 2 and you can put on your answer. And the third, the last question is that why the phase is important even when spectrum looks similar. Let's say that the spectrum's giving you the somewhere similar kind of a fault. Let's say it can be unbalanced, it can be misalignment. So why phase is important in such cases? So for this answer, please put on 3 and answer your whatever answer you like. Okay, so answer all these in the comments, and the best answer will be featured in the next skill talk video. So thank you guys, thank you for trusting us, thank you for being with us. We'll meet you in the next video with another topic. Till then, take care and be with the skill talk. Okay, thank you, take care, bye.